Hello students, today we are going to do the derivation and the topic is general equation of plane progressive wave and this is a very easy derivation. At first, what is plane progressive wave? So it is the wave in which the disturbance or the state of motion is continuously transmitted along the same direction. Okay, so disturbance is continuously transmitted in same direction. That is called plane progressive wave. And now, uh, as we know, sound consists of longitudinal waves in which every particle O of the medium through which a simple harmonic wave is propagating executes simple harmonic motion throughout its mean position along the direction of propagation of wave. As the disturbance is transferred from particle to particle after a definite interval of time, there is uniform retardation of phase in the direction of propagation of wave. So let us consider the wave is traveling from left O to right A in the figure, and let A be amplitude and Y be displacement after time t, and omega be angular velocity. Then the equation of motion of particle at O is given by y is equal to a sin omega t, which can be written also as y is equal to a sin 2 pi n t, where n is the frequency of the vibration. And if we let P be any particle at distance x from the origin and the wave be traveling with velocity v along the direction of x-axis, then the particle P will start vibrating x by v seconds after the first particle O starts vibrating. Okay, so here, if something say this will vibrate for this, the particle at O will vibrate, and then the particle at M will vibrate x by v seconds after x vibrates, as x is the distance and v is the velocity. So this particle at M, or say this particle at P, will vibrate at after x by v seconds after the first particle. Okay. We already let equation 1 and 2 lastly. Now equation of motion of particle for P is given by y is equal to a sine 2 pi n t minus phi. Okay. As we know, difference of time equals to time period t corresponds to a phase difference of 2 pi. Also, change 2 pi in phase occurs between two particles separated by a distance lambda. So if two particles are separated by a distance lambda, the phase difference between them will be equal to 2 pi. We know that. Okay. Similarly, if two particles are separated by a distance x, then that is x, let me see. The phase difference between them will be equal to 2 pi by lambda into x. And this is simple unitary method. Okay. If two particles are separated by distance lambda, then the phase difference will be 2 pi. And for x, it will be 2 pi by lambda. Lambda will be divide, it will go down, and x will multiply. So from equation 3, which we wrote already, and we will substitute the value of phi, as we know that phase difference is phi. So we will substitute that into the equation number 3 and see what we got. We get this. Y is equal to a sine 2 pi n t minus 2 pi by lambda x. So this can also be written as y is equal to a sine 2 pi n t minus x by lambda. I took 2 pi common, and then this is equal to a sine big bracket 2 pi bt by lambda minus x by lambda. Since frequency, I write here frequency n is equal to v by lambda. Okay, frequency is equal to v by lambda, and this is the formula. And we use n is equal to v by lambda here, and then we can write this equation as a sine 2 pi by lambda vt minus x. Okay, and we call it equation number 4. we find our displacement, which is equal to a sine 2 pi by lambda vt minus x, and this is equation number 4. So this is the general equation of plane progressive wave of amplitude a propagating with velocity v along the direction of x-axis. If the waves are traveling in negative x direction, then the equation of the wave is like this. Now y is equal to a sine 2 pi by lambda vt plus x. If the waves are traveling negative, it's just like this, in graph. Like the O is here and say A is here, say particle P is here, and this is traveling negative axis. Then we write here plus, and if there is in positive axis, we write minus. So in conclusion, we can write y is equal to a sine 2 pi by lambda vt plus minus x. And this is the general equation of plane progressive wave. This is the general equation of plane progressive wave. Okay. Thank you. This was for today.